I welcome all of you on a platform of YourPD Education, and you are watching the regular interview question videos which we are sharing with you based upon the actual interview questions asked in ongoing public sector interviews. So this question I have taken from strength of material in one of the IOCL interviews shared by some student, the feedback they have given. This question is related to strength of material and theories of failure. You know, in strength of material, theories of failure is a very important topic. There are a couple of theories of failure, 5 theories of failure, depending upon ductile material and brittle material. There are a couple of theories of failure. So question was, if I give you a cast iron cantilever subjected to torque at the end, tell the plane at which it will fail and draw the Mohr circle and show me the plane on that. Is the question clear? There is a cantilever of cast iron subjected to torque at the end, and आपको ये बताना है कि कौन से plane पे fail होगा. If I give you this plane as let us say plane AB, transverse plane, तो ये कौन से plane पे fail होगा, at which plane it will fail, draw the Mohr circle and explain, and which theory of failure you are going to use for this. There are 2 questions in this. Now let me explain it to you. Let me tell you the meaning of this. You know, theories of failure दो तरह की होती हैं. Theories of failure, only you need to remember 2 things. Theories of failure for ductile and for brittle material, remember the 2 names. Brittle material, cast iron is the example of this, and maybe steel is the example of ductile material, mild steel or something, ductile material. Distortion theory or shear strain energy theory can be used for ductile material, and principal stress theory can be used for cast iron. Why? Because the shear strength of ductile material is lesser compared to brittle material. So ductile materials normally fail in shear mode. They fail because of shear stress. Their shear strength is less, and hence when the induced shear stress exceed shear strength, the ductile material will fail. Brittle materials on the other hand have little better shear strength compared to ductile material. That means they do not fail in shear, they do not fail because of shear stress. Brittle material fail because of principal or direct stress. So brittle materials fail because of principal stress, ductile materials fail because of shear stress. Their shear strength is poor, their shear strength is good. Now cast iron is a brittle material, so sir I will use principal stress theory. So it will fail where the principal stress is there, you know, sigma 1, sigma 2, so it will fail where there is a principal stress. Now let me give you the diagram which is given to us. Let's say this is a cantilever, forget about the material now, let's say it's a cantilever, and let us say I apply the load, I apply the shear stress or load on this, or torque on this. I applied a torque on this, something like this, right? So what I did is I basically induced the shear stress in this, you know, there is a shear stress T over J, tau over R, so those kind of equations you already know. So there is a shear stress induced because of this torque. So torque induces the shear stress. Now because of this torque induced, at which plane, AB plane is the plane which I give you, right? AB plane पे जो हमारा induce हुआ है वो torque induce हुआ है, shear stress induce हुआ है. So AB plane is the plane where there is a shear stress which is induced, right? So how do you draw the load, basically the Mohr circle for this? The body is subjected to shear loading only. This is what, right? This is the basically body which is the shear Mohr circle drawn for this kind of loading, because shear stress is induced. So body का Mohr circle ऐसा होगा. This is shear stress, let us say tau, this is also tau, this is also tau. So there is no normal stress, only shear stress, because torque is applied on the body. Now if it is a ductile material, it will fail because of the shear stress. Now this one is what? This one is the principal stress. This one is also principal stress. These are the principal stresses. This is the shear stress. This is the shear stress. Now, the brittle material will fail at the plane where shear stress exceeds their principal stress exceeds their strength of that particular material. So, what happens is, had it been ductile material, something like mild steel, it would have failed at this very plane, AB plane. Had it been the ductile material, it would have failed at this particular plane only, transverse plane only. And that plane for us, AB, that is the plane for us. This one is AB plane. And at 45 degree to that, it is the AC plane. Let's say 45 degree, this is the AC plane. So 45 degree पे हमारे पास आ गया AC plane. अब because brittle material it is going to fail on the principal stress, because of the principal stress. So it is going to fail at 45 degree. So that is the plane at which it is going to fail. So if he asks you at which plane it is going to fail, you will say, sir, it is going to fail at this particular plane, which is at 45 degree to the AB plane. You take any plane, whether you take this or you take this, at this plane it is going to fail. This is how you are going to answer for this particular question. तो कौन सी theories of failure से fail होगा and किस plane पे fail होगा? This was the question asked in IOCL, and this is how you have to answer how it is going to fail. So there were two variation. One, the loading उसने लगाया है, वो loading basically आपका shear loading, ये वाला loading है आपका. This is the loading he has given you, right? This is the loading he has given you. तो एक तो ये लोडिंग है, शेयर लोडिंग है, तो उसका मोहर सर्कल डायग्राम ऐसा बनता है. दूसरा, मटेरियल उसने का ब्रिटल ले रखा है, डक्टाइल मटेरियल नहीं है, तो ब्रिटल मटेरियल सब्जेक्टेड टू प्योर शेयर लोडिंग, हाउ इट फेल्स, दैट वाज द क्वेश्चन. आई होप इट इज क्लियर टू यू. जस्ट रिवाइज इट वेल and revise such kind of questions. Thank you.